In the previous video, I attempted a long rocker repair on my VW bus with a replacement that didn't fit right, resulting in cracking warped metal from too much heat and a very unsatisfied Brandon. I think most people restoring cars would slap filler over the repair area, but my uncontrolled perfectionism really wasn't happy with the durability and cleanliness of my previous repair. Looking back, I definitely should have bought a taller replacement panel, and welded a little bit slower to control the heat, but my beginner skills at metal shrinking and planishing was no match for the warped metal, so I decided to start completely over. Also, I got more than 5 likes on my last video, and I'm a man of my word. This is the first rust repair, probably not the last, that I'm having to cut back out and redo. I was interested to see how easy or difficult the rocker panel came out, much depending on the quality of my welds at that time. I also needed to rethink how the new panel was going to fit against the supports. One of the reasons the warping was so bad on the last repair was from the heat of welding the supports to the rocker panel. I think this time around I'm going to try something different in those areas. My welding honestly needs improvement, as we can see from the sheet metal carnage I just cut from the bus. And like all good welders, I blame the machine. I paid $50 for this 120 Lincoln Electric flux core welder on Marketplace 3 years ago, and converted it to MIG after I learned of the even more destructive nature of flux core welding. I've watched other more experienced restoration shops use TIG, and I was envious of the control, the precision, the malleability. I never thought this would be in my future. Until a few weeks ago I received an email that led to a very heavy box dropped at my door. And here's how that went. Okay, so TIG welding is way harder than Ryan at Crucible Coachworks makes it look. I destroyed the bottom of my supports removing the rocker panel, so I need to remake that curved flange that the new taller panel will secure to. And to accomplish this, I will use a sheet metal shrinker stretcher and match the curve of the new piece, and then weld that onto the bottom of the pillars. One tip that I heard repeatedly in the TIG community was the need for the gap between the two metals to be as tight as possible. And this isn't as easy as it sounds, but thankfully, I had some practice with the last few rust repairs. No marker or pen is going to work for this. Any type of scribe is definitely the way to go to get that perfect panel gap. Another useful tool I've accumulated in this process is a long aluminum straight edge I picked up at my local metal supplier. Taking the time to make sure my support flanges are perfectly straight will pay off when I secure the new taller rocker panel on. Epoxy Primer is probably my favorite coating in this process. So far, it's never let me down like some other paints we won't mention. With that being said, 2K spray cans are expensive, they really don't go far, but I was all out of my usual stuff and couldn't have moved on without this rattle can of Epoxy Primer. This area, it's not going to be available for much longer and it needed to be covered. When everything is finished welded in this area, I'll come back and spray cavity wax as a final protectant. Where the two panel surfaces are touching, I'm leaving bare metal for now. Now normally, I screw everything into place, but sheet metal screws oftentimes mangle up the metal, and you can only reattach it once or maybe twice before new holes need drilled. CLECOS are the answer for this. Created for the airline manufacturing industry, CLECOS are a spring-powered temporary fastener for sheet metal. MRO Tools was kind enough to completely transform my life with CLECOS. My family, however, has all but banned me from saying the word CLECOS. Now armed with CLECOS, TIG, and a taller rocker panel, there was really only one more piece of the puzzle to redo this repair: glue. I was skeptical at first to use panel bond, but I now know that was my inexperience. 3M panel adhesive solves issues like corrosion between the panels, warpage from welding, and it creates this insanely strong contact surface bond after a work time of about 90 minutes. And I needed every bit of those 90 minutes. It's really important to create a smooth, even layer of glue over the whole rocker panel before finally securing it to the support flanges with metal screws. Another benefit of using panel adhesive is the manufacturer designed it to work with spot welding, creating another corrosion-resistant pinch weld with adhesive between it. I use this method to weld the bottom of the rocker panel to the frame. At this point, all that was left was butt welding the rocker panel to the side of the bus, and I knew this is where the TIG welder would shine, but I didn't know if this is where the TIG operator would shine. So I decided just to tack the panel until I was able to practice running a bead on thin sheet metal, and not an easy task for a beginner. Any beginner TIG tips in the comments are very welcome. This whole rocker panel redo really pushed me to do more with the skills I had, and learn a bunch of new skills that were stressful at times, but I think it paid off with the knowledge and the experience that will make the next repair even better.